right, this is the last video, and we will not be as behind when we come to class next week, a week from today. So this is the back of the section that says 1.2, and I'm on the back of the first page. And so what I'd like you to do is look at this first series of shapes. Go ahead and check them out. And I'd like you to write down, if you can, pause the video, and write down two separate groups that you could divide these shapes into. Okay, so for example, I'm going to give you an example. You could classify these shapes into groups where group A are four-sided shapes. And group B are shapes with more than four sides. So imagine having these shapes in front of you, like in a Ziploc bag, and you pour them onto the table. You could separate them. So this pile has four sides, and this pile does not have four sides, or has more than four sides. All right, so pause the video and see if you can organize them into different groups with two different characteristics. All right, pause it, and then come back on. All right, I'm looking at, you could maybe say group C and group D if you wanted to reorganize them. You could say group C are shapes with right angles. And group D are shapes with no right angles. Right? You could talk about perhaps shapes with parallel sides. Like these shapes have parallel sides. And this shape and this shape do not have parallel sides. You could talk about concavity. So if this is if the side's kind of been punched in like this is called, it's concave in. You could talk about shapes that are concave in and shapes that are not, that don't have this kind of concavity to them. Anyway, so this is this idea very early on that kids are presented to be able to start organizing data. When my daughter Gracie was in kindergarten, she had a homework assignment, and it must have been like manipulatives that kids, that parents, that teachers ordered a kit online, because she had a bag of buttons. And in the bag of buttons, there were these big wooden buttons. They were really, really big, like that. There were buttons that were squares. There were buttons that were triangles. And there were buttons that were circles. And then, so they were all different shapes. There were red buttons. Some of them were red. Some of them were yellow. And some of them were blue. And then some of them had 2 holes, and then some of them had 3 holes or 4 holes. So they were asked to divide the buttons into, I think probably some of them had 3 holes too, maybe something like that, into different piles. So it was pretty easy for Gracie to divide them up into reds, the blues, and the yellows. It was okay to divide them up into the squares, the triangles, and the circles. I remember it was a little uncomfortable for her because some of the squares were different colors. So the reds, the yellows, and the blues she was solid with. To divide them up, there was red squares, red circles, and red triangles. But then to have to put the squares of different colors together, that was a little uncomfortable, and that was really very hard for her to see that, to divide them up into shapes that had 2 holes, 3 holes, and 4 holes, because then you had shapes that were mixed up and the colors were mixed up. but it was a really good exercise into start seeing a commonality among different sets. Okay, so let's talk about how you can describe sets. So there's 3 ways. You can describe your sets in words, you can make a list, and then we're going to look at set builder notation. So the sets that you need to be familiar with are the natural numbers, whole numbers, and the integers. So a capital N in words, this is listed as the natural numbers. You might have learned them in a previous class as the counting numbers. All right, now to denote a set, when we've talked about this, you need a little squiggle. So n would equal, well, you start counting with the number 1. So 1, 2, 3, 4, ... So that's how you make lists of elements in a set. W means the whole numbers. And the whole numbers are the natural numbers with 0. And we're going to go ... Okay. I are called the integers. And I consists of the set of numbers that are the whole numbers and their opposites. So this is infinite in both directions. So you need that ... going off in both directions. And integers are introduced to students. It looks like I was peeking at some Engaged New York 6th grade. That's when they start talking about the opposites of numbers. Those are integers. That's a 6th grade concept. And then we're going to look at what's called set builder notation. And this is on an OWOW for this upcoming, you'll get one this upcoming week. So if we had to describe set T in words, it's not a very specific name, but I'm hoping that you'll see it's multiples of 10s. It's multiples of 10s, starting with 10 and ending with 120. Okay, so if I said, hey, I want you guys to write down all the multiples of 10, starting with 10 and ending with 120, you should be able to generate that list of elements. So let's look at what's called set builder notation. So set builder notation is set notation, right? So we're going to define it with a little squiggle. And I'm going to build it, and then we're going to see if it makes sense. So set notation always starts off the same. It's all x's such that, and we've looked at that in a previous video. That line means such that x equals to 10 times some number. Now we need to tell everyone that that number is not a fraction, that number is not a decimal, where n is a member of the natural numbers. And then the smallest n would be n times 1, right? And then n times 2. Or, I'm sorry, 10 times 1 would be 10. 10 times 2 is 20. 10 times 3 is 30. So we want to say where n is stuck between 1 and the biggest value we have to multiply the 10 by is 12. So if I give you set builder notation, you should be able to generate a list of numbers. So this would be all x's such that x is going to be some number multiplied by 10. This number is a natural number, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, ... And it starts with 1 and it ends with 12. So if I start with 1, 10 times 1 is 10. Then 2, 10 times 2 is 20. Then 3, 10 times 3 is 30. And you're going to keep doing this until you get to 12, and 10 times 12 is 120. All right? Now let's practice some set builder notation with E. So E in words are the even numbers. All right? So if I had to list E, that'd be 2, 4, 6, 8, 10, 12, right? So I'm hoping that you're going to see that these are multiples of 2. Just these are multiples of 10. 10 times something. These are multiples of 2. So 2 times something. So for set builder notation, we're going to have, it always starts the same, x such that. Okay. X is equal to 2 times some number. And let's see if this makes sense. Where the number we generate is just a natural number. Okay, and that's it. Now let's see. Remember, the natural numbers are 1, 2, 3, 4, 5, 6, and on and on and on. So if we take the first natural number and multiply it by 2, that gives us 2. If we take the next natural number and multiply it by 2, 2 times 2 is 4. If we take the next natural number, which is 3, 3 times 2 is 6. If we take the next natural number, which is 4, multiply it by 2, that gives us 8. So do you see? You don't need a restriction because this is an infinite set. So you just need to tell the viewer, hey, you take any natural number, multiply it by 2, and you're going to start generating these even numbers. All right, so you do have a set builder notation on the OWOW I'm going to give you on Monday. And then the last little bit is just talking about what finite and infinite sets are. So finite sets have a countable number of members. Finite sets have a countable number of members, of elements or members. Right? So up here T would be finite because we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12 members. Infinite sets do not have a countable number of elements or members. I hate to use it has an infinite number of members because you're using the word to define it. So infinite sets do not have a countable number of elements or members. Here I'll split off the of. Number of elements or members. So the set E, right? The set E, the evens, the naturals, the wholes, the integers, these all have an infinite number of elements in them. And then the last little bit is just starting to organize these very, very basically on a Venn diagram. So I'm just going to pop this in the corner and then we'll end this video for tonight. Just starting to organize if you were the numbers, number set. We're only going to just start because we have rationals and irrationals, but just starting to organize these. The smallest set that we're going to having to define, I'm not going to take off the E's, are the natural numbers, right? These are the basic old counting numbers. And then if we pop in a 0, do you see the whole numbers are all the natural numbers, but the only element that would exist in this ring would be 0, right? Because we've got the 1, 2, 3, 4, 5 in the n, and then if we tack on a 0, the whole numbers are one element bigger, and then all of the whole numbers are integers, but what would go in this ring would be the negatives. So we're going to keep building on these concentric circles to develop our number set. Okay, so that is the last video. When we walk into class, we will not be so far behind, losing a whole week of work, and we will review this material and then jump in with both feet, working on this, the punchline algebra, and we still have to finish this off, this worksheet off, and then we're going to look at some examples out of the book. Okay, and that will end Venn diagrams. So we will be ready for our first test. I'll bring in the review on Monday, and we'll have our first exam the Monday after. All right, I'll see everyone in a week.